Hi, in this video, we will learn how to perform the Laplace transform by using the table. You can use this table as an appendix to convert the time domain signal into the Laplace domain signal. We have 25 Laplace transform formula, and we will discuss it one by one in this video. For the first formula, the ft is equal to 1, then you get the Laplace domain signal fx is equal to 1 over x. So when you perform Laplace transform of the ft equal to 7, what is the answer? So by using this formula, you know that you should get 7 over x. So if ft is equal to constant c, then you should get the constant c over x. In the second formula, when you convert the ft equal to delta t, you will get fx equal to 1. Delta t is the direct delta function, where you can see there is the impact force occur at time equal to 0 here, and the amplitude here indicate 1. So you should know that when you perform Laplace transform on this delta function, you should get the answer equal to 1. Laplace transform of t, you get 1 over x squared. Laplace transform of any polynomial with t power of n, you get n factorial divided by x power of n plus 1. So by using this formula, try to solve the Laplace transform for t power of 3. So you can see the tn, n is equal to 3, so you just substitute 3 inside this formula, then you can get this. So 3 factorial means 3 multiplied 2 multiplied 1. Eventually you get 6 there. So n plus 1, you get 4. So this is the answer. In formula 5, if you perform the Laplace transform of exponential et, then you get 1 over x minus a. So try to solve this. So in this case, when you compare, your a is equal to 5. So substitute inside here, you get your Laplace transform result where your a is 5. So if you have negative 5t here, then your a is negative 5. So negative becomes positive. So negative 5t, you should be able to obtain this answer. So based on formula 6, try to solve this. Where you can see Laplace transform of this, you can get this answer where you just need the information for a. So in this case, a is equal to 5. Substitute inside this formula, you get 1 over x minus 5. So this is the answer. So we can use formula 7 to solve this. So when we apply the Laplace transform for the t power of 3 exponential 5t, so based on this, your n is equal to 3 and your a is equal to 5. So substitute the n and a into this formula, then you should be able to obtain this answer. Let's continue. So when you perform the Laplace transform on sine 10t, you should aware that your sine, the general formula is sine omega t. So in this case, your omega is 10. So you can use this formula to obtain the Laplace transform result, which is this. So number 9, you have cos omega t. So if you perform the Laplace transform on cos 10t, so in this case, substitute this formula where you have x over x squared plus 10 squared. So this is the answer. So next case, you have exponential in sine, so you refer to this. So exponential, you have a here. Okay, so your a in this case is negative 5. So substitute negative 5 here, you get positive 5. And your omega is 10. So with that, you obtain this answer. Next, you have exponential in cos, where your a is negative 5, your omega is 10. So substitute inside this formula, you have x minus 5, therefore at the top you have x plus 5. So this is also the same as plus 5, your omega is 10. So this is your answer. So then you have hyperbolic sine omega t. So your omega is 10 in this case. So substitute inside this, then you get the answer. Lastly, number 13. So you have hyperbolic cos 10t. So substitute the omega to be 10, then you get the answer. Pay attention to the sign and hyperbolic sign here, where you can see one is positive, another is negative. And also the cos and hyperbolic cos. So you can see one is positive, another is negative. Number 14, you have a constant A and constant B. So A and B is constant. So ft and gt is the time domain signal. So when you convert to Laplace domain, then you get this result, where your AB constant remain, ft become the Laplace transform fx, and gt become Laplace transform gx. So let's try this example. So from this example, you see your constant is 3 and 4. So this is your AB constant. So sin 10t is your ft function, and hyperbolic sine is your gt function. So you can take out the constant, and Laplace transform of ft, it should be fx. So Laplace transform for the sin h 10t is the gx. So you have learned how to solve this previously. By using the formula 8 and 12, you should be able to convert sin 10t to be this Laplace transform result, as well as the sin h 10t. So this is the answer. So from the formula 15, try to solve this. So you can see your A is 1 here. So substitute, you get the answer. Quite straightforward, you get this. U indicate the unit step function, where you can see initially it will be 0. So at time equal to 1 here, you see the function have a unit step, means the magnitude will increase by 1 and keep constant afterward. So if you have t plus 1, so your unit step function will be at t equal to negative 1. So in this case, you expect at t equal to negative 1 here, initially it will be 0, and at t equal to negative 1, it will increase to 1 and then become constant afterward. Try to find the Laplace transform for ut plus 1. So in this case, to find the A, the formula is t minus A. So in this case, your A should be equal to negative 1. So that when you substitute, you get t plus 1. So since your A is negative 1, based on this formula, substitute negative 1 inside, you get exponential s. So you should get positive there. Next, you want to perform the Laplace transform for this function, where the function is delta bracket t minus 1. So it means the direct delta at t equal to 1. So you should expect at t equal to 1 here, you have one impact force function, where the duration is very small. And the amplitude here is equal to 1. So based on this formula, your A is equal to 1 here. So substitute inside the function here. So exponential negative 1x. So with that you obtain this answer. So next, you perform the Laplace transform for t minus 5 multiplied with unit step t minus 5. So this is the graph. Initially it's 0. At t equal to 5, it start go up with a linear trend. If you compare the formula here with this formula, so you see ut minus a is equal to the component here, which is ut minus 5, and then ft minus a, you should be obtained equal to t minus 5 here. So you know from here your a is equal to 5. With that, we can let the a equal to 5 here. So you have the exponential negative 5x, and your capital Fx is the Laplace transform for ft. So what is your ft? So proceed from here. Your ft is equal to, since this is t minus a, which is t minus 5, so if you have the t is equal to t minus 5, then t minus 5 here can be represented by t. So you can have the ft equal to t in this case. By using the formula 3, you can find the Laplace transform t. Then this is the result. From formula 3, if you have the ft equal to t, you get the Laplace transform of the t equal to fx, which is equal to 1 over x squared. How if you perform the Laplace transform for the exponential 5t multiplied with t? So in this case, we can use the equation 18, where your a is equal to 5, your ft is equal to t. So you should get the result in fx minus your a is 5. So this is the answer. So you can see that for this fx minus 5, you want to know what is the answer, you refer to your fx. So if you have fx equal to 1 over x squared, so if this is x minus 5, so the x here will be replaced by x minus 5 as well. So with that, you obtain this answer. So if you perform the Laplace transform on derivative, so which is delta f over delta t, you can obtain the x Laplace transform result fx minus with the time function ft, where your t equal to 0. So if you perform the Laplace transform for the second derivative, you obtain this, where you can see x squared minus x power of 0, which is 1, and then you have fx, so initial condition f0, f prime 0, so this is the answer, and this is the general formula. Let's use this formula to find the Laplace transform of the third derivative of x. So since your n is equal to third order, so you have x power of 3 minus x power of 2 minus x power of 1 minus x power of 0, and x power of 0 is equal to 1. So small letter x indicate the time domain. So when you convert to Laplace, you have capital letter x, and then initially you have xt, second you have s prime t, next one is x double prime t. And you should know that this is initial condition when your t is equal to 0. T equal to 0 here. So these are the initial conditions. And this is your final answer. If you have integral and you want to perform Laplace transform on it, you can use the formula 21. So since the function f tau is equal to sine tau, so your ft will be equal to sine t as well. So when you take the Laplace transform of ft, which is Laplace transform of the sine t, will be equal to capital Fx. By using the formula 8, you should be able to obtain the Laplace transform of sine t. So this is the answer. Let's say we want to perform the Laplace transform on t multiplied with the delta function t minus 2. We can use this formula. So in this case, your ft is equal to delta t minus 2. And from formula 12, we can obtain the fx of the delta function. So the fx is Laplace transform for the ft, you get the answer to be exponential negative 2x. By using this formula, substitute your fx inside the formula, you get this. Differentiate the exponential function with respect to x. So negative 2 multiplied in front, you get this answer. And negative can be simplified into positive 2. So these are the final answer. So if you have a function divided by t, then we can use this formula. So your ft is equal to delta t minus 2. So in this case, your fx is equal to exponential negative 2x. So substitute your fx inside this formula. Then you perform the integration with respect to x. You get divided by negative 2. So substitute your limit infinity inside. You get exponential negative infinity equal to 0. So you have 0 here. Then you minus with substitute x inside. You get this. And lastly, negative negative become positive. This is your final answer. Sorry, there is typo here. So this should start from 19. Formula 19, 20, 21, 22, 23, 24. So 19 to 24. So with that, we have last formula, 25 here. So in time domain, you have ft convolute with the gt. So be careful, this is a convolution operation. So what is operation? You should learn plus, minus, multiply, and divide. So this is not operation. So the normal multiplication operation, it is indicated by x symbol, but this symbol indicates the convolution operation. So convolution between ft and gt is equal to the integration from 0 to t. So f tau multiplied with gt minus tau with respect to d tau. Or you can compute it in this way. So you take the ft minus tau multiplied with g tau. So both of them give you the same answer for the convolution. We have one example here. Let's say we want to perform Laplace transform between the t power 4 convolute with sine 2t. So t power 4 is your ft, sine 2t is your gt. So it will be equal to Laplace transform of this, where your f tau is equal to tau power 4. So there is a power 4 missing here. Please correct this. And sine 2t, so your t becomes t minus tau. So you have sine 2t minus tau. And then over here you have ft minus tau. This is wrong. Your ft minus tau should be equal to t minus tau power 4, and your g tau should be equal to sine 2 tau. So when you perform the Laplace transform on this, what is the answer? We can refer to this formula. You get the answer to be fx multiplied with gx. So this is your ft. Your ft is t power 4. So what is the fx? You find it. And then sine 2t, you find the gx. And then multiply the answer between them. By using the formula 4, the Laplace transform for the t power 4 is equal to 24 over x power 5. And then Laplace transform for the sine 2t, by using formula 8, you can obtain 2 over x squared plus 2 squared. Multiply between them and you get the final answer. With that, we have complete all the 25 formula, and based on this formula, you should be able to perform the Laplace transform and convert from time domain to the Laplace domain. Please make sure you master this. This table serves as an appendix. You can always refer to it instead of memorize it.